Evening, everybody. I don't know if you've seen the YouTube short that I did about this STEMotor, but today we're going to go through trying to make another one, and we'll look at the materials and what's involved in making it. So the actual base, let me get the battery out. So the actual base is off Makerverse, and it's only a few grams of filament and takes approximately 30 minutes to print. I'm going to see if I can bodge something up so you don't need access to a 3D printer. This is the bottom of a chewing gum container. I've just glued the magnet to the bottom of it, and we'll see if we can get that working. So we've got the base, two 10cm lengths of 1.3mm bare copper, no insulation on it, 40 centimeters of 0.6mm enameled copper wire, and some fairly strong magnets. So first off, let's get another base and we'll try and recreate this one. So this is the kit I put together. Basically, we have an AA battery, a template for winding the coil, the base with a pre-glued magnet, a small section of sandpaper, the 0.6mm enameled wire, two lengths of 1.3mm wire, and some extra magnets. I've just glued a washer into the 3D printed box just to keep them stuck in. So we'll go through the cost of everything and we'll take it from there. Luckily, I had most of these in. So 1.3mm bare copper wire. I think a 5 or 10 meter roll is £6. 0.6mm enamel copper wire. I think there's 25 meters on there, and I think that cost £8. The box, the base, 3D printed, few hours on the printer, and less than 200 grams of filament. The actual magnets were £3.50 for 20. The sandpaper, couldn't tell you, it was just in my toolbox. The coil winding template, again, it was on Makerverse. I think it was a 20-minute print and only a couple of grams of filament. The battery holder was just an hour of my time and some filament. But I mean, the battery holder, the winding template, you could substitute the winding template and just wrap it around a pen. You don't need it there, just make life more convenient. Right, so let us start. So on the bottom of the actual base, you won't be able to see it, but there's a hole right through into the battery compartment. The battery compartment is labeled positive and negative. There's a hole through and a channel where you run the copper wire on both sides. So let's start by running the wire through from the battery compartment out of the holes in the top of the stand. Right, I'm going to cut these a little longer and I can trim it down later. So I'm going to take approximately 10 centimeters. Right, so I'll feed it into the battery compartment, leaving 5 millimeters out. Bend it in place and push it through the hole so it comes out the top. It is quite difficult to get through, so I'm going to use some little jewelry pliers to try and make it easier. There we go. I will cut another approximate 10 centimeters in length. And again, we'll do it on the positive side of the battery. Again, 5 millimeters or so. Through the actual hole to the top. And then we'll put that to one side, and then we'll get approximately 40 centimeters of wire for the coil. Take the spindle or a pen or whatever you've got. So I'm going to give myself 5 centimeters at each end and just wrap the coil around. Then we're left with a coil and 2 tag ends. So I'm going to try and get them as opposite as each other as possible. I'm just going to feed it through to keep the coil nice and tight. There we go. So we want the tip of the coil to be as close to the magnet as humanly possible without touching it. So approximately there. So what's that? We want the loop in the holder to be 3 centimeters up off the base. So I'm just going to hold start there. So I want the loop to start there, and the loop to start there. Now this is the bit I found most difficult in putting these together, is actually trying to put a good loop into the copper wire. Oh. We'll try it. I'm not going to, I will edit the video, but I'm not going to cut out any of the hardships of making this. Have I messed up? So if I feed this through, no, the coil is going to touch the magnet, so I'm going to have to adjust the stand, at least on this side. I think that's going to be okay. Now, this is the painful part of the whole process. Because it's enamel, we have to sand the enamel off each end so it'll make contacts with the posts. You can't use bare wire because it won't induce a magnetic current. So I'm just going to sand it on a piece of card. It should go shiny as you reveal the bare copper from underneath the enamel. Right, let's see if that's enough. Right, let's deal with the actual battery terminal ends. So I'm just going to bend the wire out the way. I'm going to bend it up on both sides. What I have found is that it's a really tight fit. So let me trim the negative side of the battery down. Can you see that? I don't know if it's picking it up on camera. The actual magnet is influencing the copper coil with the current going through it. Let's try it. No. Alright, let me take the coil out. I am going to check whether there's actual voltage on the stand. Right, let me get my multimeter. And there's 1.6 volt differential between the stands, so it has got power. So let me do some more sanding. As I say, in the other one that I made, this is the bit I hated the most. No, let me get the multimeter again. I'm going to check for continuity between the stands through the coil. Yeah, we're at we are open circuit. More sanding to do. Let me check the continuity without it being in the stand. Yep, conductive. Let's try again. me just try and lower. I'm just prizing the stand apart to see if I can get it lower to the motor, lower to the magnet. There we go. I'm gonna pull the stands apart just a smidge more. And you can see the actual magnet taking effect on the coil. There we go. So they're a fiddly little thing, aren't they? I think this one's running actually better than the other one, the original one. Well, for approximately maybe £2, we've got a complete motor kit. The problem is you need to spend at least £6 and £8 on the copper wire if you haven't got it. But there's the ability to do hundreds of these. You might be able to find them in smaller reels. I mean, this is 2mm stuff, and I think that was £6. Right, I'll bring you back in a few minutes and I'll see if I can get the one set up in the chewing gum container. I'll see if I can get this one to work. Right guys, I'm going to admit it was more hassle than I could have ever imagined to try and get it working with the chewing gum pot. In the end up, I used a couple of bits of wire taped to the desk, and it's working fine. There are a couple of things to point out, if you don't mind me saying. 26,000 children a year get taken into A&E, casualty, the emergency room, whatever your country calls it, due to swallowing magnets. They are quite dangerous. And the other point is the copper wire gets warm. Although it's only 1.5 volt battery, the copper does get wire. The copper wire does get warm. It's just the same as a heating element, so just be wary of that. I hope this has been fun to watch me struggle, and I hope you have a go yourselves. Thank you very much. Catch you next time.